The work that we have been trying to summarize with the International Roundtable on Criticality, as I said before, ended up with lists of critical raw materials or not. So I have selected a few of these, let's say, methodological frameworks for some further discussion. I'm starting with the work that I know more in details because I was for a few years in the European Commission Joint Research Center and the one leading the scientific part behind the revision of the methodology that the European Commission has applied in 2017, 2020, and now for the list of 2023. But no worries. I will move very quick to the United States, to Japan, to other areas of the planet to give a more interesting international overview. This is one picture that has been used already in the discussion when it was time to revise the European Commission methodology, and it shows more in details what are the starting point for the, let's say, calculation of the supply risk. Let me also talk about that in terms of what is numerically more important and what is less. The concentration of supply measured through the HHI index is definitely one very important. It is associated to an indicator that gives an idea or a rough measure of the country risk, which is WGI. So these two parameters are combined together. So HHI and WGI. So this gives a measure of some element that help understand what could be the source of the risk, WGI, and then the more the supply is concentrated, you have the effect so-called all eggs in one basket, the risk will increase. So what we have done at the European Commission, trying to, let's say, refine the methodology, is that we corrected the first calculation of the risk, including some elements to measure potential trade distortion by different measures that some countries or government take. This shows in this slide two pie charts, one that is for the global supply and one that is specific to the supply to the EU. We have combined this measure using import reliance. And this let's say, first measure of the supply risk for the EU has been somehow connected also to factors that could mitigate the risk. The first one is recycling through an indicator that we called we call end-of-life recycling input rate, which represent how much of the current supply is coming from recycling. We started trying to understand how much this could decrease the risk. And this is one of the other items I recommend you to pencil for the final discussion. Here, the starting point and the working hypothesis is that recycling is risk-free, which it was already let's say, discussed in the morning. It is not. And that's the potential to decrease the risk from primary supply. And this is what we have done. Then this calculation is further expanded with another mitigation element, supply risk mitigation factor, which is substitution, calculated through, let's say, guided methodology, and this complete, let's say, the overview of the supply risk calculation according to the European Commission methodology. I think these are, let's say, most interesting elements that we want to keep for the final discussion. The other axis for the European Commission is the economic importance. I only want to highlight that this is calculated at the entire economic system level. So there is no focus on any sector specifically. So I'll go back to this point soon. And the calculation of the economic importance, that is clear overestimation of the economic importance of raw material, is just a connection to the economic sector in which it's used. So the idea is that if you don't have the raw material that feed into that sector, you will lose the sector, which is something that could be discussed. And again, here we have a contribution of a substitution index that could somehow rebalance this overestimation of the economic importance. So you all know that the list, the 2023 list of critical raw material for the EU was published just a few days ago. And you know, because they were also shown this morning by Milan Grohol, which are the materials that were added to the list and only two that were removed from the list. Let's go to the next stage and let's say link to the talk of Milan Grohol in the morning, where he presented the sub-list of strategic materials. And these, we know, are those that have a particularly high importance in a strategic sector. So it's not anymore economy-wide, it's a strategic sector. And they have, let's say, a forecasted huge expansion in demand. And this is the connection to one of the JRC reports that have been published together with the 2023 list. And there is a serious, let's say, concern about the possibility to expand supply. So this is, let's say, something that we might connect to the first slide, a screening and then a more detailed assessment on something more specific. Let's move to the United States and start to see a methodology, the one developed by Professor Tom Gradle from Yale University and colleagues, that has, first of all, 3 axes, so more similar to the UNECE approach, and 3 axes that represent one supply risk, similar to the discussion we had before, with the parameters that are identified in this picture. I highlight one on the, let's say, geological aspects, which are not used in the calculation of the European Commission. And these geological aspects are used in the calculations in terms of reserve to production ratio. Well, this is called depletion time, but it's a different way to call something. Recycling is used in that same parameter to understand in which way recycling could extend the expected lifetime of reserves. Then there is another dimension, which is the impact of supply disruption. And finally, one dedicated to environmental implications, calculated using life cycle assessment, the EcoInvent database that represents the from cradle to gate impact associated to the production of metals or materials. It has not been used by anybody to do any list of critical raw materials. At some point in the United States, the United States Geological Survey started developing their own methodologies, and they ended up with a list of critical minerals in 2018. I will say a few more words about that. In this, let's say, conceptual framework that was published in 2017 by the USGS, you might see some of the elements of the first slide. A first stage screening with a list of potentially critical commodity and a watch list, and then some recommendations for the next stage. I summarized and put together a lot of stuff in this same picture to show the path towards the list for the United States. the first release in 2018, and the second one published in 2022. The evolution of the United States have been, let's say, much less continuous in comparison to the evolution in the EU about the European Commission. So it started in one way and it ended up in some other ways. In the most recent methodology of the United States, there are 3 parameters that are used, one of which is likelihood of supply disruptions, which is horizontal, consistently with the scheme of the National Research Council 2007-2008, a vertical axis, which is the impact of supply disruption, another parameter that is the exposure to trade, so how much the United States are dependent from import, which is the size of the bubble, and then the combination of the 3 parameters, that is the supply risk. And based on the combination of the 3 parameters, you have the materials that end up in the list of critical raw material for the United States. So this is a little bit more details on the information that is needed, starting from the left, to calculate the likelihood of supply disruptions, which has some elements very interesting in my opinion, because it also tries to understand the willingness or unwillingness of countries to supply the United States, which is something methodologically quite challenging and interesting. The intermediate part in the center, the trade exposure, and the one on the right, which is a quite more refined methodology to understand where the material is used, in which way, and how much of the, let's say, profit of company can come from that, from those materials or not. So this is something quite interesting in my opinion. This I can go through very quickly. Is a larger picture in comparison to 2 slides ago, with the 2 axes plus the size of the bubble for the trade exposure and the color for the supply risk, including calculations that the USGS have done to monitor in which way this supply risk can change in time. For doing this type of exercise, it's very important that the exercise remains a screening exercise. Otherwise, you cannot repeat that annually or even less than annually. Let's go and skip one slide still for the USGS and move to Japan. Japan, we know from the many meetings we had in the trilateral US, Japan, EU, that is very active on criticality assessments. And this is one of the, let's say, public publications, public information that is disclosed, because actually the criticality assessment by the Japanese government are not disclosed. So we know they are using the European Commission methodology for their calculations, but we do not know the outcomes, and we do not know the list of critical raw materials for Japan. But this is one of the, let's say, applications of a few years ago, on which I want to highlight one aspect. So it just takes me a few seconds. The supply risk, which is calculated with the methodology of the European Commission, is reapplied 3 times. One based on global suppliers, so country consultation, WGI. A second time to the countries from which Japan is importing the materials they need. And the third time calculating global concentration based on reserves. So this is the other aspect I wanted to highlight. To rebalance, because I used many slides and I'm getting to the conclusion, to rebalance a little bit more towards Japan, because I already had one slide. I also want to show this one, which is a very interesting study by Dr. Hiroki Atayama from AIST, Japan, that published a very interesting study to analyze reported cases of supply disruptions. the assessment was done over 500+ cases of supply disruption. So it's curious that this is one of the few studies that instead of trying to understand the potential for disruption, trying to see, based on statistics, whether what we are trying to calculate is correct or not. And you might notice that most of those reported disruptions are related to metals that we do not consider critical, or we did not consider critical until a few months ago, not even years, a few months ago, like some of the base metals. And the main reasons for supply disruptions are accidents at the mine level, strikes, and fall in metal price. So being one that have been active and engaged in this criticality assessment, I ask myself whether we are able to try to, let's say, predict or estimate or assess this type of possible supply disruption. So this is my slide, so my last slide. So most probably I did it nearly in time for the 30 minutes, even if I would like, but you know, when you invite university professors for lectures like this, you never know how long they could talk. So here are the three axes of the UNFC, and I just put a few elements just to stimulate the discussion, but then I stopped talking and I open the discussion with the participants in the room. Let me start with the G-axis. It seems that the G-axis is not so important in criticality assessments. If you still remember what I tried to highlight, there is a small space in the Yale methodology, which is, however, not used for any list of critical raw materials, is not considered at all in the current list of the critical minerals for the United States. It is partially used in the calculations that I have shown to you in the case of Japan, and that is not used by the European Commission. The Japan, I say, allow me to guess, because as I said, I do not know the final methodology. When I spoke the last time, and it was a few years ago, to Professor Shinsuke Murakami from University of Tokyo, to whom I was talking in view of their methodology, I say, okay, but now I'm helping you, but when you have done your work, could you share the results? And he say, no, I'm sorry. I cannot do that because the government will never allow me to do something like that. So that's the G-axis. I would say the E-axis is the one on which probably we want to concentrate most of our discussion, because it was highlighted in the morning. On one hand, this is, let's say, the real power of UNFC, but we also seen that is the, let's say, it's the tricky part in understanding in which way criticality can be somehow mitigated. And moreover, as some or more than one colleague in the last month said, it's time to stop talking about criticality assessments, and it's time to start talking about criticality of projects. So I think this is something net positive that can feed our discussion. And the X-axis, in which, of course, technological aspects are the most important ones, but the only connection I could try, and I recognize it's not that much interesting, is the one on substitution, because substitution is something related to technology and, let's say, innovation in technologies and other things like that. So I would stop here, and okay, thank you for your time and for having, let's say, left some of the sandwiches outside and accepted to come for the lecture.
Thanks, Gian Andrea. That was give him a hand. Thanks for really lecturing and also leaving us with some questions, maybe, and some comments. Or, is there anyone from the audience that would like to? Yeah, please.
Gian Andrea, my question is, do you think that a critical list should be public or remain confidential, as it is done in Japan, according to the importance that can be used for investors, for whatever. So what's your feeling now that you know there are different options?
Well, my feeling, I can speak freely because I'm not anymore in the European Commission. So I'm finally free to put together. No, well, no, I was trying to bring some level of joke inside this very serious discussion. I think that if the exercise remains a screening exercise, as I have tried to highlight at the start, this can be made public. The discussion is on the short list, so the second level. So what's important for strategic sector, based on a more detailed assessment, I have the impression that the Japanese approach is more correct, because this would probably, let's say, disclose information to competitors that is probably better not to disclose. So, well, I think maybe making some confusion with my slide and with my talk, I also gave a correct picture of the confusion that we have around the discussion on criticality assessments. So I was in the end correct, probably.
Thank you. Yes, please.
Thank you very much, Professor, for your presentation. And yeah, so the critical list or the assessment, I mean, it keeps changing due to the various battery chemistries, that we have. We can talk about the lithium iron phosphate, the NMC, among others. Currently, we have the sodium ion battery chemistry, that is gaining traction in China. Some vehicles, have already been produced that are using it. I just want to ask, have you assessed critically the sodium ion chemistry and its sodium part of the critical minerals or elements, that you have assessed? Thank you.
Thank you. Thank you for the question. It's a very good one. It's also something I'm discussing at the national level in Italy. It's a very important one. So if the criticality assessment remains a screening exercise and you can do it in real time, probably you will spot problems with new materials, because in the case of the sodium ion chemistry, we are talking about a new material. Well, not on Earth, where it's super abundant, but let's say in the industry, in the potential for production. So I'm not aware, well, I'm not. I know there are criticality assessments done by some study groups, including for that specific technology. I don't think that neither the European Commission or the United States or Japan have done anything like that, but everybody should prepare for doing like that. And if you can deploy this screening exercise quickly, this is, let's say, the best way to face problems. The discussion I'm having at the Italian level, just to complete the response, suggests to some that it is not worth to study criticality because things are changing too fast. So when you fix a problem, you will have another one. I'm completely against this position because we ended up in the situation where we are, where we cannot react in time because we neglected the problem for too long. So if you are ready, if you study the problems, and if your, let's say, system is ready to react, you can always face a new problem. So you keep the pace with evolving technology, and you keep in mind that whatever technology you will use in the future, you need the raw material to support it. So this is my, let's say, my argument when I speak to the, let's say, the politicians in Rome. And I tell you, it's not an easygoing discussion. But I imagine that for let's say, the vast majority of Europe, it's not so far.
Thank you. Yes, another one. Yes, please, go ahead.
Aside from the Aleph group. I'm raising this question within the context of it is a discussion, so please be patient with me. If somebody has to build a communication strategy and wants to rely on documentation or a source or an authority for two things. Number one, what is the origin of criticality? When did it start? Number two, how can it be defined? I know that's possibly it's an evolving concept and it's going to be defined according to the needs of the various stakeholders. But presumably there will be somewhere where that beginning of defining it is to be found to substantiate and enable any communication strategist to start from it. Thank you.
No, it's a very good point, and you do not have to apologize for anything. So it's perfectly in line with the discussion. Criticality assessment is basically a communication tool. So this is something important to say. So normally, people that are very active in the field of mining, for instance, because I'm a member of the Society of Mining Professors, are not really interested in criticality assessment. So criticality assessment is a screening exercise, so a very superficial analysis that is mainly done to explain to others that have no clue what are the problems with identifying a mineral deposit and transforming a mineral deposit into a mine, why minerals are important. From the communication point of view, I would say that we are bulletproof because most of the discussion, even though the parameters are different, the way you combine them, the concept of having a risk of supply disruption, which is combined to the importance of the raw materials, can create problems to your present or your future. That's something sound that can be used in any case for communication purposes. So this is my point of view. I'm quite convinced about. So this discussion on our real capacity to identify the real problems, it's something it might be interesting in this case because we are people that understand what we are talking about. So it's when we go outside, you understood let's say, life becomes complicated.
Thank you. And I do see another hand. Please, sir, go ahead.
Can you hear me? Actually, this picture here with the three axes, I think it's an interesting aspect to think about the risk. The risk is actually the vulnerabilities into it. Why not look at all of the axes as part of the vulnerability? Because the challenge to get access is actually that the vulnerability is extremely high in order to get the project started. So the vulnerability of each axis actually is necessary, I would say, and will give you actually very low access, which is what happens in real life. So G-axis, for example, it's no better than what is being explored, than it's been allowed to be explored. The potential might be there for much higher, but the potential is not the same as what you have at hand. Similar is the F-axis. It always needs to be, we have basically a lot of technologies, but they need to be tailored to each case that we have. Similarly, as the E-axis has also to be tailored following the IA legislation and all the challenges there.
Yeah, I think if you allow me to build a little bit on what you said, it seems to me that it could be a good idea to start using these three axes to, let's say, suggest this list of critical projects and identify them according to risk associated to the different aspects that with UNECE you can identify. So this is, I think, an interesting starting point, maybe for the next month, if you agree.
Absolutely, thank you. And okay, you sir, go ahead.
I have a question or remark on your substitution. And I have first one comment is that when you have a criticality assessment, basically you are telling to your private sector, please invest. Your substitution, and to have a mine is 10 to 15 years. So if substitution is coming too quickly, then you may give a wrong signal, which I think comes to your point that you should really look far ahead so that this thing is matching. My question on substitution, we are always talking about substitution from a technology change. Now, what I do observe is that sometimes we create our own burden on what is available for good reason, like environmental reason. Do you take into account as substitution a possible change of regulations which will make possible something which today is not or no longer possible? I mean, just to give an example, permitting in now for renewables and nuclear, there is a try to shorten the permitting because it's so important. So there was plenty of things which will not be done the same way, hopefully with the same strictness, but not the same way. And the same way we see the list of products you can have in which has been restricted for health reasons, sometimes just because you don't know, so you don't use them, right? So one way of substitution could be, I come back to this and I relax, for instance, this constraint on health because I don't know, so it may not be that, but for instance, so is that something that you take into account in substitution in your work?
No, thank you. This is a long one on many meetings in 2015, 16, 17. I remember that we spent always 60% of our time on substitution and didn't have enough time to discuss about the rest. But this, it's something just my observation. You might have noticed that in the paper of the AIST Japan, Atayama et al. The second most important reason for supply disruption was the fall in the price, and normally fall in the price is also related to too much availability of substitutes or not enough demand, or okay, and this is a bad luck that quite often is underestimated. So another element that I want to add to what you said. The calculation of the supply risk, taking into account the substitution or the calculation of the economic importance of the vulnerability to disruption, taking into account the substitution, is made of mostly mapping possibilities. If you go and look at the numerical results of the methodology, you will discover that, especially in the case of the European Commission, the relative weight of the substitution index is very minor, or sometimes not even existing, because the idea is to have a mitigation factor. And we know that substitution cannot mitigate quick enough, or let's say cannot be effective enough. So most of the work that has been done, and I speak about my work when I was in the European Commission, was to identify substitutes. How many we have, if they can be deployed or not, how much is the cost, how much is the performance, making sure you are not substituting something critical with something critical or that will become critical, making sure that the current production is enough to cope also with the potential substitute and other things like that. But numerically speaking, there is no contribution of substitution. We did this exercise underground and it was never published, but the list would not change if substitution would be done in a different way. However, it's a huge amount of information that it is included in the fact sheet with all the possibilities to substitute. And then the industry will do that. We will continue on that path because, well, substitution is done by industry. So when people will find a better substitute, they will use it because it will perform better and will cost less. And this is normal, but we understood that it's low. And this is the reason why it does not give any, let's say, illusion of being a mitigation factor. I hope, because, you know, the discussion of substitution is, it's really tricky, it's really tough.
Yes, please, sir.
Ignatiy Volnov, the Society of Petroleum Engineers. Actually, this is a nice topic we just touch about the risks and the mitigation, because of this three-dimensional diagram shows the comparison between the knowledge, which is the degree of confidence or the uncertainty, which can be resolved with the future, with the more and more study, and the decision that has been done with the specific technical solution and the specific the reflection of the socio-economical viability and the process. But both of the E-axis and F-axis is the economically driven axes. And frankly speaking, the economics is the only one parameter who controls both of these axes. What is the necessity to divide these two in the two different parts? Because otherwise, the previous colleague said about the risk. You can just set up the economy and the work with the risk mitigation instead of the trying to control uncontrollable. The question is the difference between E and F is not this clear as the is represented, because the economy controls that. How can you define that?
Okay, I'm not the right person to respond to this question, but I will try. Maybe I will succeed, but in case I say something wrong, somebody will immediately jump on me and say, no, shut up. This is not the way it works. I think the economic aspect rule both axes, but in a very different way. So one is connected to technology, and this is something that you can quite easily predict. So this is the work for engineers or economists that work in a company and can understand clearly the picture, because using that technology in that, let's say, physical condition will result with a cost of production, and so the economics work or not. The other one is the economics of the unpredictable, because it involves social aspects, governance aspects, and things that have nothing to deal with engineers. So correct me if I'm wrong, but the difference between one and the other are the engineering part, which in one case the horizontal one is key, in the other one is not enough. Is it acceptable?
Charlotte, you want to you want to explain? You're on.
Hear the lecture, which is fantastic. So you've got a question from Carlos Paiter in Brazil. I think you know him. He was in Lille. So he says, if the EU had availability of all the critical raw material list, in parentheses, the idealistic view, could EU companies process all the material needs, or would there still be some processing risk? Charlotte,
I was trying to listen to you and I couldn't. Could Could you please repeat? Yeah, the only part I understood was that the question was from Carlos Peiter. Okay.
So if the EU had availability of all the critical raw materials on the list that it needs, so he's saying in an idealistic world, could EU companies process all the material needs, or would there be still some processing risks?
Well, this is quite easy to respond because I can build on what Milan Grohol said this morning. If we have a benchmark for, is it 40% or 50% pre-processing? 40% in the EU, it means that we have a problem on processing as well. So I don't think it would be, well, this ideal world is not even ideal. It's impossible. There is nobody in this planet that can be independent. So it's not that the situation of others is much different. Mining wise, nobody is independent. But on the processing stage, I'm sure currently we have no capacity in the EU for magnesium. We have no capacity for titanium sponge. We have no, or let's say, limited capacity for a number of other metals.